Hello everyone, and today I am myself C. Rajkaran from Assistant Professor from IT Department from Kamaraj College of Engineering and Technology. And today topic I am going to discuss, we are discuss about Playfair cyber in cryptography. First, what do you mean by Playfair cyber? Playfair cyber is the first practical digraph substitution cyber. It was invented in 1854 by Charles Wheatstone, but it was renamed as Playfair, which was after the name Lord Playfair, who promoted the use of this particular Playfair cyber, and it was used in the World War I and II. And we can see how this encryption process works in this Playfair cyber. The encryption, there are two steps in this Playfair cyber. The first step is a key generation. Second step is the encryption process. We will see how the key is going to be generated. First, the key size of this Playfair cyber is 5 cross 5 matrix representation. It is represented in the form of matrix 5 cross 5. And here, when you say the 5 cross 5 matrix, the total size of this is 25 characters. So, the total alphabet size is 26. So, here we place I and J in the same place. So, it can be occupied from A to Z 25 characters. Consider how to generate this key. For example, consider the key is monarchy. So, you can see here is, you start this the 5 cross 5 matrix. You can see here the monarchy is written first, then the remaining characters which are not present in the monarchy, it should be written sequentially. You can see here monarchy is written, next B, D, E, F, G, I, K, L, P, Q, S, T up to Z, which are the characters not repeated in this monarchy. Each character should not have a repetition. So, that is the thing. And also in the ith place, J also occupies the same place. I and J comes under the same place. This is how the key generation is done. The next step is the encryption process. So, first, before starting the encryption, the plain text should be paired with a couple of characters. Pair the given plain text in the form of two characters. If the pair contains the same letter, if the pair of two letters contains the same letter, we have to insert the least frequency of the letter and repair it. For example, when we have LL, then that particular LL character should be separated as LX and XL. So, that is how. So, now we can see, and also another one rule is, when we are pairing the alphabets, it should have the even number of characters. If it has an odd number of characters, the last character should be added with the least frequency characters. For example, X can be added the last. So, the rule 1, there are 3 rules for encryption process. The first rule is if both the letters are in the same column. So, after pairing, we have to take the pair. So, if both the letters are in the same column, the ciphertext can be take the letter below the particular text. If the particular, for example, here we can see here plain text is a ME. So, after ME it is in the same column. So, after M the below character is C. So, for M we are replacing C, and E is after E is below L. So, for ME is converted into CL. And another one, if the plain text contains the last element of the column, for example U, then you have to take the top of the element. If going back to the top, if at the bottom, if the text is present at the bottom, you should take the top of the element of the text. So, this is the rule 1. The rule 2 is, if both the letters are in the same row, take the letter to the right of the each one. You have to take the next element, that is right of the next element. And consider here, we are ST. ST is the plain text. So, for S the right element is T, and here when the rightmost element is the last element, you have to take the first element of the row. For example, here the T is the last element. So, we are taking the L as the alternate for substitution for T. So, ST is converted into TL. So, S is converted into T, the next element, right element is, for S the right element is T, and for the T right element is, here there no right element. So, we have to take the first element. So, L. So, TL, ST is converted into TL. This is the second rule. And the third rule is that it can be, the pair can be anywhere. So, that is it, neither of the condition is true. If it is not, it is present in the same row or same column. Form a rectangle with the two letters. You have to form a rectangle with two letters and take the letters horizontal to the opposite of the opposite corner of the rectangle. Consider here is an example. Consider the plain text is a NT. It is present in, not present in the same row or same column. So, we have to form a rectangle. Here see here you are forming a rectangle here. So, after forming a rectangle, you have to take the opposite corner of the rectangle. So, opposite corner of the rectangle is R and Q, where it meets the plain text is the ciphertext. There, here you can see here R, Q. N is replaced by R and T is replaced by Q. This is how this encryption process works. So, these are the three rules for encryption process. And how the decryption process works is the same method you are going to follow as the encryption process. Here the step 1 is a key generation, same as the encryption process, and second one is also decryption process. It is a reverse of the encryption process. For example, if it is the ciphertext is present in the same column, we have to in the encryption process we take the below element, but in the decryption process we take the upper element. So, that is a difference. And if the element is present in the row, same row, in encryption process we take the next right element, but in the decryption process we take the left element of the for the plain text. So, that is how. And for the neither row or column we take the same form, same thing, we form a rectangle, on the opposite side of the corner rectangle text will be taken. And what are this advantages of this cipher, Playfair cipher? First thing, it is significantly harder to break since the frequency analysis is higher. For example, it is a substitution cipher, difficult to use the thing. It considers 25 cross 25, totally 625 the digraphs can be formed rather than 25 monograph, which is difficult. Okay, so that is the thing. 625 digraphs instead of this monograph. So, because it is a digraph, it contains 625 pairs. And also the second one is a frequency analysis of this ciphertext is hard to break the encryption. And the disadvantages is, for example, the major weakness of this encryption or decryption process is Playfair cipher is, consider this ciphertext, AB. When we decrypt this ciphertext, it will contain the BA, which is the reverse of the ciphertext. So, that is the thing. So, we can identify the easily whether it is a reverse process. So, the plain text, ciphertext and reverse is the reverse process of this reverse element of the plain text and ciphertext. So, correspondingly it can also see here UR is reverse of RU when you are converting plain text to ciphertext. It can be easily exploited when the frequency analysis easily identified by others. So, another disadvantage of this Playfair cipher is it uses the same key for encryption as well as decryption process. So, this is the two disadvantages. So, we will see with an example how to solve this encryption process, how to solve this. Consider the example, consider the plain text is a cryptography and the key is security, and now you are going to first step what you are going to do is encryption is key generation, encryption process we are going to do. Encryption. So, first thing key generation what first thing, the key is a security should be placed in the 5 cross 5 matrix, S E C U R I T Y, security. Next, remaining elements or should be filled with the A to Z, which is not repeated in the security. So A, B, C is already present in the key C. So C we have to omit. Next D, E is already present. F, G, H, I and J are present in the same position. So we are omitting I and J. K, L, M, N, O, P, Q, R is already present. S is also already present here in the key. T is also already present. U, V, W, X, Y is already present, Z. And this is the key matrix. Now from this we are going to process the from plain text to ciphertext. The second is the first step in the encryption process is we have to create a pair of two elements. We can pair it. Pair of two element pairs. What are the pairs we can form in this is first CR, YP, TO, GR, AP, next final is HY. This is a pair we have formed. Now from this we are going to convert the plain text into your ciphertext. So we will see first CR. You can see here from CR where it is present? It is present here, CR. It is present in the same row. Same row means what you have to do is we have to place the next element to the CR. C's next element is U and R next element is here, it is the right of the element, so there is no element, you have to take the first element, so US. So CR is converted into US. Next you have to take Y and P. You can see here Y where is present, here it is Y and P is present here. Y is present here, P is present here. Y, P. So here it is neither present in the same row or same column. So we have to form a rectangle. Rectangle we are forming means here we will get B and N. Opposite side of rectangle text is BN. Next TO. Next pair is TO. TO is T is here and O is here. Once again it is not either present in row or column. Once again you have to form a rectangle. So rectangle form means we will get AM. Next element GR. Where G is present? G is present here, R is present here. So once again it is not present in the same row or same column. Once again in form a rectangle we will get KC. Next AP. Where A is present? A is present here, P is present here. So once again in form a rectangle, it is not present in the same row or same column. So once again in form a rectangle, we meet at B and 0. Instead of AP we get B0. Next final pair is HY. Where H is present here and Y is present here. So once again it is not present in the same row or column. It is when we form a rectangle we get G and A. H and H replacement is G, Y replacement A. So, this is how the encryption process. So, the final ciphertext is US BN AM KC BO GA. This is a ciphertext. So, this is a encryption process. So, next we will see how to decrypt this ciphertext and to plain text. Once we decrypt this ciphertext to plain text, you will get the original plain text, that is cryptography. We will see how to do it. Decryption. Decryption. So, first step is the same, similar to encryption. We are going to do is the key generation. So, already we have done the key generation. So, I am not going to say the same thing. So, we will keep this key as the same thing. So, we can pair. The second thing is the pairing of elements. Pairing of elements. This is the ciphertext. We have to pair the elements. So, how to pair? US, first pair. Second pair is a BN. Third pair is a AM. Next is a KC. Next is a BO. And final is GA. This is the pair of elements you are going to pair. Next once again you have to convert this pairs into a substitution text. For example, US once again. US you take it, consider U and where is S? Here is S. So, it is present in the same row. For decryption process, you have to take the left of the, when the row, same element is present in the, two elements is present in the same row, you have to take the left of the text. So, you take U left element is C and S left element, there is no left element. So, you have to take R, C R. Okay. Now, US is converted to CR. The next element BN, you can consider once again B is here, N is here. So, we convert this BN into, so form a rectangle, you get Y and P. You can see here YP is the opposite corner of the BN. Next AM, where is M? A and M. Once again it is present in somewhere, you form a rectangle. Form a rectangle means opposite corner is T and O. T and O. This is a, for AM replacement is TO. And next pair is KC. Where is K? K is here, C is here. Once again you form a rectangle, that is K and C. For K replacement is G and C replacement is R. GR. Next BO. Next pair is BO. Once again B and O. It is present in the form, you have to form a rectangle. So, the opposite corner is A and B when you form rectangle, A and P. And final pair is GA. So, GA, where is G? G is here, A is here. The opposite corner is here, H and Y. H and Y. So, now we have formed the, we have created a decryption process. You combine and write the plain text, you will get the plain text. So, the plain text, the final plain text is CR YP TO GR A P H Y. You can see here the original plain text cryptography, we are given as a input. We got the original plain text after decrypting the cryptography. So, this is the process of the Playfair cipher for encryption and decryption process. So, So, this Playfair cyber is mainly used as a 5 cross 5 matrix key operations. So, you can easily understand this from this video how to perform the Playfair cyber. Thank you for your listenings.